Hello. In this session you will learn some basic technology terms, which are important to better understanding the NetACE environment. In this module, there are 4 parts that briefly introduce the following terms: NetACE northbound interface and southbound interface, data model, net conference, YANG, REST, API, JSON, DL1, microservices, RPC, gRPC. In the following part, we will cover the NetACE northbound interface and southbound interface and basic concept of data model. The NetACE support variety of APIs. On the northbound interface, it supports the most common APIs today, such as REST API, gRPC and more. It allows easy integration between the NetACE to the upper layer, third-party OSS. For example, the third-party OSS tool can create a service with its tool based on the service models done in the NetACE. The third-party tool reads all the network inventory by the REST API protocol. The NetACE southbound interface supports various communication protocols towards the network devices, such as netconf, YANG, CLI, SNMP, DL1, SOAP, XML, SFTP, mTOSI and Chorba. What is a data model? A data model is a diagram with set of tables and the relations between them. Looking at a model always easier to understand than looking at a list of tables. It is better to understand the table purposes. Data models help represent what data is required and what format is to be used for different business processes. Designing a data model is based on 3 phases: conceptual, logical, physical. The conceptual data model can be written on a piece of paper and can be easily changed and modified. It is a set of square shapes connected by lines. Square shape refers to an entity. Line refers to relationship between entities. Abstract means not too much details. All 3 entities have a direct relation to the sales entity. Relations are also abstract, while relation is also column, which this is not clearly defined yet. Entities are visible, while attributes are not visible. No software tool is required for designing the conceptual data model. When the conceptual model is ready, we can look for the logical data model. Logical data model expands the conceptual data model by adding more details to it. There is presence of attributes for each entity. There are key attributes and non-key attribute. Key attribute uniquely identifies the entity. Non-key attribute can be found in other entities. There are direct relations between primary key and a foreign key. Key attributes can be used also as primary keys. At this stage, this logical model is not depending on any specific database, means you can take this logical model and implement it in any database. It can be Oracle, SQL and more. Available tools to create logical data models are ERWin and Power Designer, which automatically convert the logical model into a physical models. Physical data model. In physical data model there are some definitions: entities referred to as tables, attributes referred to as columns, database compatible with table names and column names. Database specific data types can be integer, char, float and more. It is difficult for users to understand and will include indexes, constraints, triggers and other database objects. Database objects means stored procedures, functions and more. Data model summary. It is a simple diagram, shows a list of tables and the relationships between them. There are 3 stages in designing a data model: conceptual, which is highly abstract; logical, which is entities and attributes; and physical, which contains tables and columns along with data types and additional database objects. It is specific to a database. Before we'll introduce in high level some of the most popular APIs, let's understand the background. It is about the need for new developments that will answer the common challenges that telecom operators are facing since a decade or more. Network operators demand for radical and clear enhancements of their current limited performance of OSS, NMS and DMS systems, in order to manage and maintain their growing and complex networks. The major operators' demands are: ease of use, from the operator point of view, necessary to make clear distinction between configuration data and operational state data and statistics and being able to compare between devices, ability to configure the network, rather than individual devices. Demand for standards for pulling and pushing configurations from more to the network devices as desired, for backup and restore of configuration as an example. And the requirement that devices should hold multiple configurations. Thank you. Please join us in our next session. Intro to NetConf and Yang.